The video lesson before this introduced you to elasticity of demand. Here's a quick summary of it. If E of x is less than 1, then demand is inelastic. Inelastic means even if prices were raised, people would still buy it. An increase in price will lead to an increase in revenue. Gas is a good example because even when gas prices go up, we still have to buy gas. So even when we have a price increase, we might drive a little bit less, but we don't have much of a choice. So ultimately, the oil industry has an increase in revenue. If the elasticity factor is greater than 1, then the demand is elastic. Elastic means an increase in price will lead to a decrease in revenue. An example of a good that's elastic is, let's say, Netflix. Let's say Netflix cost $100, then I wouldn't buy Netflix, and I'm sure a lot of you guys wouldn't either. So Netflix would lose a lot of customers if they changed their price to $100. So that would lead to a decrease in revenue because they would lose a lot of customers. When E of x equals to 1, the total revenue is maximized. And this is called unit elasticity. So anytime you want to maximize revenue, set E of x equal to 1. And just to keep consistent with the notation, even though this formula has an x in it, I'm going to change this to a p because we're going to look at the elasticity of demand with respect to its price. So let's change all of these to p's to keep consistent notation. Okay, so change all of the x's to p's. All right, let's look at an example. We have a demand function d of p is equal to 400 minus 3p to the second power. Find the elasticity function. So because, again, this demand is in terms of price, we want to find E of p. Now let's look at the formula. E of p is negative p, I'll write this down, times d prime of p divided by d of p. Okay, so we have here, we got negative p. D prime of p, this is a constant, so the derivative of that is 0. The 2 multiplies with 3, this becomes a negative 6p divided by d of p, which is 400 minus 3p to the second power. A negative times a negative is a positive, so the elasticity function is going to be 6p to the second power divided by 400 minus 3p squared. Now, we want to find the elasticity of demand at a price of $3. So here's what it means. If this item costs $3, how elastic is the demand? In other words, if we increase the price, would people still buy almost the same amount of goods that they were buying before at $3? Okay, so the elasticity at $3 is equal to 6 times 3 squared divided by 400 minus 3 times 3 squared. Okay, and then this comes out to be 0.144. The elasticity at $3 is 0.144. Now what does that mean? When E of x is less than 1, the demand is inelastic, which means even if the price was increased, the demand wouldn't decrease significantly, so therefore we would have an increase in revenue. Okay, people are still buying the same amount, except now it costs more, so there's going to be an increase in revenue. So at this price, we would say the demand is, because E of x is less than 1, the demand is inelastic. And based on this, to increase revenue, we should raise prices. Because if we raise prices, the price goes up, but, so this is your price, it increases. The quantity it stays the same. So price increases, quantity stays the same. This means your overall revenue is going to increase. Okay, here's another example. Suppose a demand function for a product is given by d of p equals to negative 2p plus 192. Calculate the elasticity of demand at a price of $55. So let's find out what our elasticity function is first. Okay, so remember, this is given by p times d prime of p divided by d of p. So this is going to be, and there's a negative. So we have negative p times d of p, it's just going to be negative 2. And all of that is going to be divided by negative 2p plus 192. So negative 2p times negative p, this gives us 2p divided by negative 2p plus 192. That's our elasticity function, but we want to find the elasticity at a price of $55. So in other words, if this item costs $55 and prices were increased, would the demand stay unchanged? So we have 2 times 55 divided by negative 2 times 55 plus 192. And if we evaluate this, this will give us 1.341. So the elasticity of demand at $55 is 1.341. Okay, now let's go back. What does that mean? If the elasticity of demand is greater than 1, then demand is elastic, which means if you raise prices, the demand will drop significantly, and that'll lead to a decrease in revenue. Okay, so the elasticity of demand is 1.341, and therefore we should not increase prices. At what price do you have unit elasticity? Unit elasticity is when the elasticity function, which is 2p divided by negative 2p plus 192, is equal to 1. Okay, once again, unit elasticity, this happens when the elasticity function equals to 1. So first I'm going to move this to the right by multiplying it. So I'm going to multiply both sides by negative 2p plus 192. Multiply this side by negative 2p plus 192. So this cancels out. If you distribute the 1, we get negative 2p plus 192. Move 2p to this side. We get 4p is equal to 192. Divide everything by 4. And we're going to get the price is equal to $48. So at $48, we have unit elasticity, which means at $48, we maximize revenue. Okay, another example. Given the demand function DAP equals to radical 225 minus 4p, how many products will be sold if the price is 27? Now, the DAP just means the demand at a price of p. So the demand at $27 is equal to 225 minus 4 times 27. And if we simplify that, then this will give us 10.816. But we can't sell 10.816 items, so this is approximately 11 units or 11 items. That's how many items will be sold when the price is $27. Now let's find the elasticity function. So the elasticity function, once again, I'll write the formula. It's negative p times d prime of p divided by d of p. So we have negative p times d prime of p. I'm going to rewrite this as 225 minus 4p raised to the 1/2 power. So the 1/2 comes to the front times 225 minus 4p. And then you subtract 1 from this, that's going to be to the negative 1/2 power. Do not forget about the chain rule. When the parentheses has a variable, we have to multiply by the derivative of this as well. And the derivative of this is just of the parentheses will be negative 4. So that's the numerator, which we will have to simplify. And on the denominator, we just have d of p, which is square root of 225 minus 4p. Now let's simplify this. First off, we have a 2, and we have you have a negative times a negative, that's a positive. We have a 2 and a 4, so 2 goes into 4 twice. So here's what we're left with. We're left with 2p times 225 minus 4p raised to the negative 1/2 power divided by the square root of 225 minus 4p. But remember, we cannot leave a negative exponent. This goes to the denominator and becomes positive 1/2. This whole thing goes to the denominator, becomes a positive 1/2, which is a square root. So we have 2p. We have this square root there, which is radical 225 minus 4p. But then, when this goes to the denominator, it's going to become positive 1/2. So that's also the square root of 225 minus 4p. And if you multiply the same expression, square root times square root, then the square root goes away. So our answer is 2p on the numerator and 225 minus 4p on the denominator. Okay, so we have 2p on the numerator divided by 225 minus 4p on the denominator, and that is the elasticity function. In my open math, you might have this unsimplified where you have a 2 on the denominator and a 4 on the numerator. Just remember that those simplify, and your answer should be 2p over 225 minus 4p. But that's the correct answer. What is the elasticity of demand at a price of $27? So the elasticity of demand at $27 is equal to 2 times 27 divided by 225 minus 4 times 27. And if we simplify this, this gives you 0.4615. So this means that the elasticity of demand is less than 1. Less than 1, it means that demand is inelastic at that price. So if the price is $27 and the price increased, people would still buy the same amount. So because it's inelastic, to increase revenue, we should raise prices, because even if prices were raised, guess what? People are still going to buy your product. Now, what price will maximize revenue? Revenue is maximized when EFP is equal to 1. So our EFP, our elasticity function, is right here. It's 2p over 225 minus 4p. So we're going to take 2p over 225 minus 4p, set it equal to 1. First thing is we want to multiply this to the other side. So that's going to give us 2p is equal to 225 minus 4p. Move the negative 4p to the other side by adding it. So we get 6p equals to 225. We're going to divide both sides by 6. So p is going to equal to $37.50. So when you set the price equal to $37.50, the revenue is going to be maximized.